Once again, my students, let me hope that we are doing fine, and those who are not fine, we pray that you get fine too. This is your friend, teacher Kenya Innocent, the teacher of chemistry and mathematics. And today we are back, we are still moving with the UNEB 2025 UCE examination paper for mathematics that our friends have just done recently. So I want to thank those that have been following item 1, item 2, item 3, and today we are here for item number 4. Now, I'll still advise you to tell a friend, and subscribe to this channel so that we get in touch and we revise much of the math and chemistry through this platform. I told you last time about what we expect in item number 1 and item number 2, the topics which are more likely to happen in those two items. And with item 3, 4, that is section B, part 1, we said that this section part 1 of section B, which has item 3 and 4, the theme there is called data and probability. And under that theme, data and probability, we have topics like data collection and presentation, topics like graphs, topics like the set theory, topics like data collection and display, topics like matrices and probability. Now, those are something like 6 topics. I told you that you may not find all the 6 topics appearing, but at least out of the 6, you may have 3 of them coming. So today, we are specifically here for item number 4. One of the cheapest items in this theme of data and probability, that is data collection. But if you look at the item that our friends faced this time round, a few students that answered it again found it a challenge. But at least today, by the time we finish this tutorial, you'll be able to understand what really and what exactly item number 4 required of us. Okay, as usual, we are going to first start by reading through this item, then we identify the tasks, we identify what you're supposed to do. It is very important to understand, to identify the tasks in the question, very important to know which data items are very important to do your analysis or to make your manipulations as far as the question is concerned. That's why we say we read through the question, then at least we shall be in line to know what exactly we are required of. We are beginning with item number 4 exactly, that is UNEB this year 2025, which our friends have just done. It said that a certain school employed a new teacher of mathematics to help the senior 4 learners to improve on their performance. Before the new teacher was employed, the analysis showed that the learners' mean score was 54% and 38% of the learners scored below the pass mark. I beg your pardon. It says that the analysis showed that the learner's mean score was 54%, and 38% of the learners scored below the pass mark of 55%. The new teacher has taught for a full term, and learners have been given an exam whose results are shown in graph 1. Now, this is our graph 1. It could be very better because according to my screen here, maybe it is becoming hard for me to have the whole page displayed here, because if I try to reduce on to zoom, again I may affect my page. So according to what we have here, you're seeing this graph, but some of you, I know you have the question papers with you. So I will beg that you have this graph with you together so that we can interpret its data, because I may not project it. I don't want to make it too small again. It may not fit my screen here. But according to what the graph shows, graph 1, showing number of learners and their scores in mathematics. So you can see on the y-axis here, or on the vertical scale, we have number of learners in brackets, that's the frequency, and this on the horizontal scale, we have the learner score, in the brackets the class boundaries. Now, if you look at this question here, they are giving us this data in terms of a graph. Hope you can see. But we are going to come to this and we are going to interpret this graph. Let us continue the question. The school needs help to analyze the results of the learner's performance shown on graph 1 and establish whether there is an improvement in the learner's performance basing on Roman 1, the mean score of the results on graph 1 in comparison to the previous mean score, and Roman 2, the percentage of learners below the school pass mark of 55%. The task says provide the school with the help they need. Now, I've been telling you all along, before you can approach any question, first look at the question and analyze it so much well. Don't just rush into the question. Please read it through. Now, after reading through, find out the keywords and the key values, or the numerical values given, which are going to guide you on answering this question. It has said that a certain school employed a new teacher of mathematics to help the senior 4 learners to improve on their performance. Before the new teacher was employed, the analysis showed that the learners mean score, that means previously, the learner's mean score has been 54%. And with that mean, 38% of the learners scored below the pass mark of 55, that previously, the mean score of the learners was 54%. And when they measured the percentage, or when they captured the percentage of the learners that scored below the pass mark, and the pass mark is 55%, which means 38% of the learners scored below this pass mark, which means this 38 is just a percentage of the learners that scored below the pass mark. And what is the pass mark of that school? The pass mark was 55%. The new teacher has taught for full term, and learners have been given an exam whose results are shown in graph 1 below. Now this is the graph. Our graph, the first step one could do is to find what do we have on the axis, on these scales. Look at the vertical axis and also look at the horizontal axis. There you can easily find out what they have given us. Now look at this. We have a graph of frequency against the class boundary, because you're seeing number of learners as the frequency, and this side you have learners scores as the class boundaries. So from that means if at all, maybe from a certain frequency distribution table, that's why they picked the frequency and also the class boundaries. Let us move again. The school needs your help to analyze the results of the learner's performance shown on graph 1 and establish whether there is an improvement. So I told you it is so important to find out the task. Look at this, an improvement. That means we are targeting at discovering whether there is an improvement in the learner's performance. And what is going to guide us in finding that problem, in solving that problem, or in finding whether there was an improvement, is the 2 Roman numerals given here, or the 2 parts that they are saying that the only way to get this improvement, we must base on Roman 1, the mean score of the results on graph 1 in comparison to the previous mean score. So before I can go to Roman 2, let us first approach Roman 1. In other words, they are telling us to find the mean using graph 1 And from graph 1, I've told you, maybe it was extracted from a certain frequency distribution table which we don't know or which we can find ourselves. So if you look at this, it is saying the mean score excuse me, the mean score of the results on graph 1 when you compare to the previous mean score. That means we need to get the average or the mean using the data provided on our graph there. And how should we get the mean using that graph? Let's look at our graph. We have the number of learners, that is the frequency, and this frequency is against the class boundaries. In other words, we have frequency against class boundaries. So when I am given frequency and when I'm given class boundaries, how should I manipulate this data to come up with the mean? In other words, and remember, formula for the mean, we know it very well. Summation of fx over summation of f. So how can I use this data to come up with that? That means provided the frequency and the class boundaries. That is my first step to determine or to lead me to the frequency distribution table, because I cannot just reach out the mean without the frequency distribution table. So let's look at my what I came up with from here. I will always advise you, please, before you can even go to the solutions, subscribe, please. If you have any browser, go to YouTube, search in the search bar, put Teacher Bukenya Innocent, and type the whole statement, Teacher Bukenya Innocent. Then type the whole word like you can see here, teacher. Type this statement here, type the whole of that word, and finish it. Then press the search bar. Then you will be seeing my channel. Please do subscribe so that any development which takes place here, you are informed and you can also be part and you can participate. Okay, now hope you can see my numbers are here. So subscribe, please. Subscribe so that we move together. Don't leave, don't just view, and don't subscribe when you view. Subscribe so that we move together. And please, I'll be ready for any correction. If at all we find anything that needs to be corrected, again, I don't chase away corrections. Please correct me and we shall move on so much well. Now, this is our graph. On our graph, we have the frequency, we have the class boundary. That means we must use those two given pieces of data to let us now fill the frequency distribution table so that we can pick out the summation of fx divided by the summation of f so that we can come up with what we call the mean. Okay, according to that table, we shall have the scores. Look at how I arranged my table. I will have a column for scores. Those are the class intervals or the class limits. I will have the column for the frequency, midpoints, fx, cumulative frequency, and the class boundaries. Okay, now why do I need, maybe I'll come to that. I'll come to that because we wouldn't put here something which is not important, but because of part B, I didn't speak about Roman 2, the percentage of learners below the school pass mark of 55%. Let's talk about this before we can even continue. Now here we need the learners that score. Actually, now besides the previous percentage, we need the new percentage now after this new teacher teaching these students. That means I'll need the number, and to determine those that scored below the pass mark of 55%, of course, this one is going to lead me to a cumulative frequency curve, which we call an O give. And we know that an O gives cumulative frequency against class boundaries. So that's why inside my table I will need that column for the cumulative frequency. That's why it is there. So I just want to talk about it before we can continue, but we shall come to Roman 2 and we see what it really requires. So our table should have a title. Hope you can see frequency distribution table, scores. Now scores, those are the class limits or the class intervals. We are not given them. we have the class boundaries. But you very well know that if you are given if you're given class limits, let us say from 10 to 14, to get their class boundaries, I know that we all know that we subtract 0.5 from the lower class limit and we add 0.5 to the upper class limit. Now look at this. Let us focus our eyes on this axis here. You can see we have 14.5, 24.5, 34.5, 44.5, likewise up to 9, like that up to 94.5. Now these are class boundaries from which actually the class boundaries that were formed from the class limits after subtracting 0.5 from the lower class limit and adding 0.5 to the upper class limit. So that is it. Now suppose because this one will give us the first class now, 14.5 to 24.5. This is the class bound. These are class boundaries of the first class. In other words, there is a class limit or a class that has been manipulated on to come up with this. And we say that on the lower class limit they subtract 0.5, upper class limit they add 0.5. That means from here I can know which figure has been subtracted. 0.5 has been subtracted from which figure to come up with that. Of course, that is the 15. That means I have 15 too. What about here? 24.5. There is a figure on which 0.5 has been added to come up with this. So that's why we have 14.5 to 24.5. So this is the class boundary. This is a class boundary. So we can have the class limits from that, which is 15 to 24. Likewise, the second one will be 24 to 34. It will be 25 to 34. Like that. So that's where we come up with. That's why we came up with these scores. We got them, I've told you, we got them from here because these are class boundaries. Maybe if I can look at this class here, something, there is a figure from which 0.5 has been subtracted. Yeah? So that is 35, because 35 minus 0.5 will come up with 34.5. So that is the lower class limit. Even here, there is a figure on which 0.5 has been added, and that is what? 44. So the class here is 35 to 44, just like that. So if you look at our table, so we have already identified now the class limits, which we didn't have before. Let us run quickly to the frequency. How are we coming up with the frequency? I will try to put red marks because my graph was not so much visible. So I've tried to pass red marks through it so that you can clearly see it. Let us come to the first class. They have said that the first class is 15 to 24. 15 to 24, what is their frequency? You come and read here. Hope you can see. If you look at that, we are saying this part here. Come and read. Which figure we having here? So that means this class, in fact, let us have it, all of it highlighted. If we can have it like that. The whole of that class, look at its frequency. Its frequency is there, which is a 15. So the class of 15 to 24 is having a frequency of 15. So school students that scored 15 to 24 marks are what? 24% are 15 students. So I'll come in my table and put what? And write 15. What about 34, 25 to 34? Still I will go and look from here. 25 to 34. Again, 25 to 34. Hope you can see it. It is here. Read what is there. It is the 30. You come and put your 30 in the frequency table. Come 35 to 35 to 44. 35 to 44 is here. 35 to 44. Look at this class also. 35 to 44. Read the frequency there, which is what? Which is 10. So I think from there you can go furthermore and find out the frequencies for other classes. Then the midpoints, which we call X, we know midpoints. We get the lower class limit plus upper class limit divided by 2. And if you get this, so here we have 15 plus 24 divided by 2, which gives us 19.5. Likewise to the next class, 25 to 34, we shall just add lower class limit plus upper divided by 2. So we have 25 plus 34 divided by 2, giving us 29.5. I know we all know how to get fx is just a product of f and x. So you multiply this frequency times the midpoint to get the fx. That one I know, we know 15, for example, 15 times 19.5 giving us 292.5. 30 times 29.5 giving us 885, like that, and so on and so forth. Likewise to cumulative frequency cone, we said that if you are writing the cumulative frequency, we normally normally write down the first frequency, which is 15. Then we go on adding 15 plus 30, that one gives us 45. 45 plus 10 gives us 55. 55 plus 45, 100. 100 plus 90, 190. 190 plus 50, 240. 240 plus 30, 270. 270 plus 5, 275. And always the last number, the last figure in the cumulative frequency column should be the same. Are you seeing? Should be the same. Actually, look at this like this. This last figure here should be the same as the figure where? As the figure there. Okay? That means your cumulative frequency is right. Then the class boundaries, for them they're already given. You can even copy them directly from your graph here, or you can still manipulate them. We said that lower class, on the class limit, lower class limit we subtract 0.5, and upper class limit we add 0.5 to come up the class boundaries. Hope you can see this is 15 minus 0.5 giving us 14.5, and 24 plus 0.5 giving us 24.5. Likewise, if we consider this class 35 to 44, I'll get 35 minus 0.5 giving me 34.5, and then 44 plus 0.5 giving me 44.5. Okay, then my table is done. Please, I still remind you, subscribe before you can continue. Subscribe, don't just watch, but subscribe so that you will be notified for any new information that is coming in. We don't want you to miss, because we are coming up with a lot of work during this December and January. So please don't miss out. So subscribe, and then we continue with this work. Please do so, and we continue. Okay, thank you. Here we are on fx. Now fx is really more, we say that it's just multiplication. I want to talk about its summation of x. F of x is just a matter of adding whatever is here. We just add all these values, and then we shall be coming up with the summation of f of x. Now, because I have the summation of fx and the summation of f, I can get the mean score depending on the mean score that is according to graph 1, like the question was saying. It was saying that establish whether there is an improvement in the learner's performance basing on the mean score of the results on graph 1 in comparison to the previous mean score. So that means they are getting to get the mean score from that table that I've just generated, and then we shall compare with the mean score in the first performance. So mean score from the result of the graph, you're saying that mean equals summation of f of x over summation of f. And from there, we know that summation of f is the total frequency, total number of students now here. So we have summation of fx, which is 15,462.5 divided by 275. So according to that, we are getting 56%. Now, this is the mean score after this teacher has taught these students. So you want to compare it with the mean that was given in the question, so that we can come up with a conclusion that says, that talks about the performance, whether the performance has improved or the performance has done what? Has decreased. So how should we compare? I compared it by a matter of subtracting. I said that difference between the new mean score and the previous mean score. So this is 56 minus 54. Remember, this is what was given in the question previously. Before the new teacher was brought in, these learners could have a mean score of 54%. But now after the new teachers come in, it has raised. By the way, just by analysis, if you can look at the two, by mere observation, you are seeing that there is an improvement in the performance, because the average score is now 56%, which is something higher than the 54% in the previous. That means there have been an improvement. But maybe I came and compared it by subtraction. I got the difference as 2%. So this was my response. Let us look at this response. I said that there was an improvement in the learner's performance since the mean score increased by 2%. Of course, we know all that if the average score of a student goes high, that's an improvement in the performance. So I came up with such a response. So during our holidays, we are going to still have much more of this. So I advise you, let's keep in touch. Please do subscribe to that channel, share it with your friends, share it with your fellow students, so that we can have a lot of mathematics come this holiday, that is December and January. Okay. Let us continue with the part 2, or I didn't label, maybe I labeled this side. Okay, but it is very good to label your work so much well. So let us first read that question. And now when we are comparing with the mean score, you've seen that there is an improvement in the what? In the performance. Now, normally too, they also want us to compare, to talk about the improvement of learners' performance using the percentage of the learners below the school pass mark. Remember, the percentage of learners originally was 38%. That means 38% of the learners scored below the pass mark, which means for us to note that there is an improvement in the performance, the percentage must decrease. That means a few students must score below the pass mark. That will show an improvement in the performance. So if 38% of the learners scored below the pass mark of 55%, and now we are looking for the new percentage, we expect this percentage to go down if there was an increase in the performance. And how shall we determine this now? Since we are getting the percentage out of the total learners, total frequencies are total learners, that was 275, which means that I must find out now the number of students that scored below 55%. After getting that number, I will divide that number with the total number of the students and then multiply by 100. After doing that, that's where now I will not see where, that's when I will come up with the right percentage. But what is now the question? We don't know how many learners scored below the pass mark according to graph 1. We don't know. And with this graph, we cannot determine that number. We can only determine that number using the cumulative frequency curve, which we call the O-give. So using an O-give, that one can give us directly the number of students that scored 55 and below. We can easily get that number. Now, what would we do? There's something we must find out here, or we must embrace in this, and that is what? If you were to draw an O-give, what do you need? Remember, it is an O-give that normally gives us those numbers scored below, scored above, scored this, we can easily determine them using an or give. What does it call for? In data collection and display, you must know what does the OGIV apply to and what does the histogram apply to. You must understand those two things. If at all you come to know that when do I apply an OGIV, when do I apply an histogram, there to be very easy for you to do what? To understand when to apply the other. But I remind you, please subscribe and we continue. Please subscribe. Just if you have already subscribed, you can know this. But if you have not subscribed, please subscribe and we continue. We are just waiting for you. Okay, do subscribe. Thank you. Let us continue. Now from there, in our holidays, one of the work we are preparing is breaking down topics. So under this, we shall also break down this, and we know when to apply the OGIV and when to apply the histogram. But according to this, we are going to apply, this is a real application of an OGIV. And we know that an OGIV has, what does it have on its axis? It has cumulative frequency against the class boundaries. And according to my frequency distribution table, I already have the cumulative frequency and already have the class boundary. So that means using this data against the class boundaries, I can come up with an OGIV, and from there I can easily determine the number, any number of a certain range of marks that I want. So according to me, this is what I came up with. However, again, my graph is a bit long. I don't know whether I can try to make it small for all of us to see, but again, it will appear too small. Maybe you can capture it and zoom it yourself. But according to me, let me try to zoom it. It is becoming too small for me, and I want it to fit my screen. Oh my goodness. But you can see here. So we have cumulative frequency, which I put in brackets, number of students, and this side I put class boundaries, which are the scores. Okay, I use the scale here, not to disturb me. I decided to use the scale horizontally 1 centimeter to represent 10% and vertically 2 centimeters to represent 25 students. By the way, we shall come up again. Sometimes some scales are not awarded marks, sometimes scales are given marks, but I will still re-advise you, and I will still call for this. Maybe in the holiday, I normally note down these things to talk about most in our holidays as we meet for these lessons. We must talk about graph work. We still have a lot of students that are struggling to get the scale, and I don't want to make this video too long, so we may not go into details of getting the scale, but just to know, during our holidays, when schools have closed, we shall get much of the time for interactions, and we shall be coming up with all this work. Graph work is very, very important, because most of the times questions that have graphs have cheap marks, by the way. It is very, very easy to score them all. Now look at this. This is the scale I came up with. 1 centimeter, that's the horizontal scale, where we have the class boundaries or the scores. I said 1 centimeter to represent 10%. Hope you can see. From 14.5 to 24.5, we have a difference of 10 marks. So it is 10. Then vertically, 2 centimeters is representing 25 students. So from there, I plotted, because I already have my frequency distribution table. I can easily plot from here 24.5 with 15, likewise, like that. So if you come out with my OGIV, I began with plotting. I normally advise you, if you're plotting here, some of you get confused from here. Let this, the lower class boundary, let it be the opener. Okay, let it be the one which opens the horizontal axis. Okay, then when you're plotting, consider now the upper class boundaries. That's why some people say cumulative frequency against upper class boundaries. So what you do, you come here. Okay, so what you do, you consider the upper class boundaries with the cumulative what? With the cumulative frequency. like that. Hope you can see. So those are the two things we plot on our or give. So that is the plotting. But what is our target on the plotting? Our major emphasis is to look for the number of students that scored below the average mark, which is 55%. And how do we get that? Come to the side of the marks, to the axis which has the marks, which has the class boundary, which are now our scores. Look for 55. After looking for 55, draw a vertical line to meet the curve. In fact, these are traced from where. So if I look at my scale here, I'm finding 55 around there. So I'll place a horizontal line until where I meet the curve. So when I meet the curve, I draw another, this is a vertical line. I will draw another horizontal line going to the left until when I meet the axis which has the cumulative frequency or the number of students. So from there, I will read, and my answer will be in terms of number of students. By the way, what is on the horizontal scale is the marks. What is on the vertical scale is the students. They will have class boundaries and cumulative. By the way, you can even put scores, and here you put number of students. That's okay, because you not get confused. Some learners don't know what to read this side and don't know what to read this side. But according to this, these are students, and these are them are their scores or the marks. Please subscribe. I still remind you, subscribe to my YouTube channel. If you're using any other browser, go to YouTube and type in Teacher Bukenya Innocent. Type the whole of this. Type it, Teacher Bukenya Innocent, and then subscribe, and you continue. Please do so, and you move on. Okay, thank you for subscribing. Let us continue. Now we are looking for this value. We've already traced it, and we are looking for where 55% is meeting the curve, and we are discovering that it is within there. And according to what the figures here, by the way, some of you don't even also know how to read these figures. I think we shall make another tutorial in graph work, and we shall be coming up with how to read this. But again, it is very cheap. Get the difference here: 125 minus 100. That which equals to 25. So if it is 25, how many small squares are there? So divide 25 by 10. 25 divided by, because there are 10 small squares, you get how many is in a small square. So 25 divided by 10, that is 2.5, which means every 2.5, every small square here is equal to 2.5. So there are two small squares from 100, which makes up 5. So 100 plus 5 will give us 105 students. Now there is something here which is very disturbing. Remember, according to the mean score, using the same data, according to the mean score, we came up with something that said that there was an improvement in the learner's performance since the mean score increased by 2%. That means even the cumulative frequency curve. Now the other conclusion, the other response has already limited us here. We must have also discover an improvement here. Now, what does it call for? We are saying that we are getting 105 students, but among these students also, we also getting those that scored exactly 55%. So this is 55% and below. And remember, the pass marker is 55. If the pass mark is 55, those who scored 55%, exactly 55, those ones cannot be taken as those that got below. If your teacher gives you a test and says that the pass mark is 60% and you score 60, you cannot be exposed to a punishment, because for you scored exactly what the pass marker wants. But those who score below 60, maybe 59 and below, all those are subjected to punishments. Likewise here. Now an UGIV is giving us students that scored 55% and below. That means even those that scored 55 are there. So what do we do? What do we do here? Now, there is a simple trick here which you must follow. In the scores or in the class limits, how do we get the class width? We are used to saying that get the upper class limit minus lower class limit plus 1. There is that one which is added, which means all the members in that range are inclusive. You understand that? The members in that range are inclusive. So if they are inclusive, then that means that we must exclude that person, that one we add, which is making up the 105 learners. Let us put off that one, because you want those that scored below the average, not the 55% and below, no, but those that scored below 55%. That scored below the pass mark, not the average, but the pass mark, below the pass mark. And which means what? Come and say. This is what I came up with. I said the percentage of learners below the school pass mark of 55%. What did I come up with? I said that the percentage, we know the percentage equals to number of learners below the pass mark over to number of learners in the class times 100. But number of learners below the pass mark, that we are not knowing them, but we have used an UGIV, and we are saying that number of learners below the pass mark of 55%, below the pass mark of 55%, and 55. Okay, this is like maybe I didn't just state it clearly, but this statement means that number of learners that scored 55% and below, which means 55 inclusive, but the pass mark is saying below 55. Hope you can get me. I don't know if you can clearly get me. That below 55 means someone who has scored 55 has passed. But if you look at number of learners that scored the pass mark of 55% and below, and 55, which means someone can, the 105 students are those students that scored 55 and others below 55. But we want those that scored, let us say 54 and below. So that's why we are subtracting this one from the other knowledge of the class limits. So I'm saying those that scored below 55%, we get this figure minus 1, coming up with 104 learners. I have told you why we're doing this from the class limits. When we are getting class width from class limits, we get 50. We get the upper class limit minus lower class limit plus 1, which means even the members in those limits are inclusive. So for this case, 105 also includes members that scored 55% also, but yet the question is what? Members that scored 55 below 55, below, that's 54% and below. That's why I'm subtracting this one to come up with 104 for learners. Then percentage of learners that scored below the pass mark of 55% is 104, which I've gotten here, divided by the total number of learners in class times 100, giving me 37.82%. Now another step is comparing. Remember, in our question, let us go back to our question. In our question, they told us what? 38% of the learners scored below the pass mark of 55. Now, if the percentage has reduced to those that score below the average, that means there is an improvement in the performance. Because if 38% scored below the average, and now the percentage has gone below which means that there is an improvement in the performance. So if we compare, I compared it by subtraction, I got a decrease of 0.18%. And this is my response. There was an improvement in the learner's performance since the percentage of the learners that scored below the average of 55% reduced by 0.18%. So that's what I managed to come up with. Please and please subscribe to this YouTube channel, and you can also WhatsApp me on this MTN number. I would be responding to you so soon. So subscribe. I've told you, if you are just using any other browser, put in YouTube and type Teacher Abukanya Innocent, type the whole statement, then after subscribe, we shall be having much. So this is not what you should miss in the holidays. This will be our targets, major areas of emphasis in December 2025 to January 2026. We shall have breaking down of topics, like I've told you. When you're making these revisions, for us, we just go through them quickly, but you want to break down every topic, all your topics of challenge. We break down them so easily so that you cannot fail, so that we make those A's together. So we shall break down topics, we shall solve the examination items, we shall look at the elements of construct. That is our expectations for each item, which topics are in item 1, topics in item 2, topics in item 3 and 4, and final topics in item 5 and 6. So we shall be coming to that. Question approach: how do you approach questions? How do you approach item 1? How should you approach item 2? Majorly these are compulsory items, so still shall be getting you. Another thing is helping you to understand, but not to cram. Remember, here in science we don't cram, so we shall be dealing with a lot. People have been asking for physics. There is a teacher who is whom I'm preparing. Actually, is left with something very small, and very soon we shall be coming up with physics here. But I myself will be taking you through chemistry and mathematics. So please, we are making these A's together. Please search now and subscribe now to Teacher Bukenya Innocent. Hope we've had enough for today. Please, if there is any question, my students, I'm very open. Just tap me on my WhatsApp. You can also comment right from YouTube. Don't forget to subscribe, and also tell a friend. Also tell your friends there. Tell the students, instead of getting on TikTok or for at least this time round, you use your data for revision. More so, senior 3 students, please. Let us, actually you're now senior 4s because the candidates have already left. So please, let us get in touch, and we shall be having a lot. So I think we've had enough for today. We shall meet again for item number 5 next time. May God bless you so much. I remain Teacher Bukenya Innocent, a teacher of chemistry and mathematics.